So now we're ready to add an axle and then test the motor. You'll notice here I can control the motor speed, but we won't be able to see it spinning unless we have something in it. So let's go into our shafts, collars, and washers. And then all that we need is a shaft. So let's switch back to the snapping tool. Let's get a 5-inch shaft and we move it so it's in position like, I can't tell which one it needs. Let's try that one. And then let's move it into the motor a little bit. So let's move it just a tad in. And if it's too long, you can also shrink it, which is nice. Let's do something like that. Now, it should, in theory, be able to spin. So if we connect it... Oh yeah, the other thing is it won't spin unless there's something on it. So we have a shaft, but unless we put a gear on it, so go to gears, then we switch to auto, and let's take a nice big gear, and let's mount it on there. Bam. Cool. You could also put a wheel on. Put a gear or a wheel, whatever you want. You could even put more than one gear. Just get crazy with the gears. Nice. And now if we connect, hopefully it doesn't all fall apart. And there we go. Whoa, yeah, cool. We can have it spinning. Really neat. And you can control the speed. And there we go. So let us just do one last thing, which is to add another gear that this one will make spin. So let's put another gear hanging out somewhere over here. So let's go to the shafts. Let's take another shaft and maybe snap it here. And then let's switch back to the move tool, bring it over. And this wouldn't work in reality, like having a shaft just hanging like that. In reality, you would at the very least, need to use shaft collars to attach it. So we'd have to put a shaft collar on there. We'd put a shaft collar on there. But in the physics simulation, you don't actually need the shaft collars. It always assumes that axles will, just to simplify the physics, they've gotten rid of some of those things. Then we go back to gears, and we need to add another gear on this. So let's do another 36 tooth, and let's line it up, hopefully like that. That looks correct. And let's cross our fingers to make sure to hope that this works. I've had issues in the past. We'll see if the gears work now that I'm using the snapping tool to try to align things. If you try to just place it without using snapping, I find that the gears or any sort of interlocking mechanisms, they won't work and it'll lock out the motor. So if you're gonna use gears or you're gonna try to build something complicated that has like interrelated parts, better to try to snap them together, and then if it's not working, delete it and snap it again. That's how I found it works. Anyway, let's see. So we run it, and there we go. We have our two gears, and one is controlled by the motor, the other is free floating, and they are powering each other. So I could do this to actually create a really simple kind of offset for my wheels. Or what I could do is I could make this one smaller. So I take, sorry, I'm getting ahead of myself. Select this, press minus, and now I switch the big gear to a small gear. And then I could select this and press plus and make that one be a gigantic gear, a 60 tooth. And then let's see how that goes. Connect it. And there we go. So now spinning this gear even slowly is going to make this gear spin incredibly fast, which is a drive motor, or a drive gear instead of a torque gear. It's giving it more speed. So depending on the gear ratios, you end up getting more torque or you get more speed, which is kind of a good thing to know when you're planning your design. So that's all for this video. The next video will be talking about how do you actually tell your motor to do things without you having to control it here. So basically, how do you use the blocky code? And I'll also be putting together a few videos to show how you take something like this and turn it into a fully functioning robot. Now, the last thing though, before you go, is make sure that the project is saved. It says save pending, and then it says if it's saved, it'll say in the little corner, it'll say saved. If it says that, then you know that you're okay. And you can also, there's a few options you can control. So if you're having trouble, you might, if your computer's having trouble, you could switch the settings to low. You could also switch the physics to between high and low. And then there's one other kind of cool thing, which is show mimic physics outlines. If you press that, and if you're having trouble with like aligning things up, sometimes the physics outlines will kind of help you know how the simulation is going to go. But most of the time, it's not needed. So we can turn that off. It's more for like debugging, I guess. Yeah, and also if you wanted to share your project, which is kind of cool, you can go up here and you can choose public, and you can choose how you want it to be shared. So including code, or they can download it, or only they can see the description. They can't actually do anything with it. It's totally up to you. And then you could take this, you could share the link. So if I took public, description, and download, and then I could say, here are the restrictions people can do on the project. Then I could actually copy the project, or, so this is like if they wanted to make a copy and start making it themselves. But if you want them to, now that I've set it as a public project, if I take this URL and paste it into like a WhatsApp or whatever, if I take this and share it with people, they'll be able to actually go to this exact project and run the code themselves and see how things go. This is really good for team collaboration as well, where you can make a quick simulation, be like, hey, here's the idea I have for our drive system. And then someone could, and you could actually test it out and be like, oh yeah, that would work. Or, oh wait, we don't have that piece. We're going to need to order that piece if you want to build this. That kind of thing. So I hope that you find this helpful, and stay tuned for more videos to go into more depth with the Robot Mesh Studio. Thanks for watching.